Hello everyone, welcome to my channel ACT, Anita's Communication Tutorial. In this video, I'll explain about light sensors, which will cover introduction, applications of different type of light sensors like photodiodes, photoresistor, phototransistor, and CCD light sensors. Moving on to the introduction part, light sensors. What is light sensor? Light sensor is a sensor that detects light and converts it into an electrical signal. A light sensor generates an output signal indicating the intensity of light by measuring the radiant energy that exists in very narrow range of frequencies that ranges from infrared to visible up to ultraviolet light spectrum. Some applications of light sensors are here. In agriculture, we all know crops need mainly two things for growth. One is sunlight and the other is water. This is where a light sensor comes into play, helping farmers to keep their crops hydrated, yet not overhydrating it. A light sensor is connected to a sprinkler system detecting the level of sunlight, and it only activates it when the sun is not at its brightest. It is used along with temperature sensors to help gather information data as well. Have you ever explored the auto brightness mode on phone? Isn't it interesting how the screen changes its brightness automatically? It is made possible with the help of light sensor. The light sensor measures the ambient light level of our surroundings and determines the suitable brightness for our screens. Apart from smartphones and tablets, they are also used in automobiles to support the driver's field of vision. For security applications, they are commonly used in circuits for shipment cargoes. Light sensors are connected to circuits and are placed inside as it can detect whenever a container is open due to change in light exposure. This helps in better processing of lost goods. Moving on to the next slide, that is types of light sensors. Here we will cover photodiodes, photoresistors, phototransistors, and charge coupled devices. First, we will discuss about photodiodes. Photodiode consists of PN junctions which is connected in reverse bias. They are similar to PN junction diode, but their outer casing is either transparent or has a clear lens to focus light onto the PN junction. They are made mainly from semiconductor materials like silicon and germanium, and they work on the principle of photoelectric effect. Photodetector consists of PN junction which is connected in reverse bias, that is P is connected to negative terminal of the battery and N is connected to the positive terminal of the battery, due to which there is a wide depletion layer is formed. So when light falls on the depletion layer, it leads to generation of electrons and holes. Holes move towards P junction and electrons towards N junction, which leads to generation of charges, which contribute to the flow of current. Thus, current is proportional to the intensity of light. Photodiodes have their applications in remote controls in televisions, smoke detectors, CD players, medical applications, and also they are used in solar panels. The next light sensor is photoresistor or LDR, that is light dependent resistor. They changes resistance when light is incident on it. It is also known as light control variable resistor or photoconductive cells. The resistance changes with light intensity that falls on it. We can see the figure on the right. There is a thin zigzag strips that is made up of light sensitive material having high resistance like cadmium sulfide, cadmium selenide, cadmium sulfonide, etc. It works similar to resistors, but here change in resistance is dependent on the amount of light is exposed to. When light falls on the light sensitive material, electrons move from valence band to conduction band, creating free electrons in the conduction band, and thus free current constitute current. Therefore, resistance decreases. But when there is no light, there no free electrons are generated, and hence the resistance increases. This can be seen in the illumination curve. This curve is plotted between resistance and light intensity. We can see in the figure, high intensity of light causes a lower resistance between the cadmium sulfide cells, and low intensity of light results in a higher resistance between the cells. This working principle can be seen in applications such as street lamps, wherein day the higher light intensity results in lower resistance and hence no light is produced. Moving on to the next, that is phototransistor. Phototransistor is like a normal transistor, but it uses light for switching and amplification process. It consists of three layers of semiconductor material and its base is a light sensitive region. It absorbs light and transforms into the current that moves from collector to emitter. When light falls onto the junction, number of electron hole pairs are generated, which increase the current. Thus, the current is directly proportional to light intensity falling into the PN junction. Phototransistor light sensor can be described as photodiode plus amplifier. With added amplification, light sensitivity is far better on the phototransistors. They are used in compact disc players, smoke detectors, laser, punch card readers, security systems, encoders, etc. And the last is charge coupled device light sensor (CCD) is a light sensitive integrated circuit that captures images by converting photons to electrons. A CCD sensor breaks the image element into pixels. Each pixel is converted into electrical charge whose intensity is related to the intensity of light captured by that pixel. Small light-sensitive areas are etched into silicon surface to create an array of pixels that collect the photons and generate electrons. This can be seen on the figure on the right side. Here, the number of electrons in each pixel is directly proportional to the intensity of light captured by the pixel. After all the electrons have been generated, they undergo a shifting process that moves them towards an output node where they are amplified and are converted into voltage. They have wide range of applications like they are used in scanners, barcode readers, microscopes, medical equipment, astronomical telescope, robots, optical character recognition, and they are also used for processing satellite photographs and radar imagery. Thank you for watching my video. If you like this video, don't forget to like, share and subscribe. Also don't forget to press the bell icon for getting notification of my new videos.